So if you weren't here, I said I was going to start off with a little bit of an angles lesson because we didn't cover this last week. So just to make sure we cover all our bases with angles, that's what I'm going to start with. And this is my table. So these are the types of angles. And if you remember properly, we actually did not speak about them at all last week. Okay, considering that we were doing types of angles, we should have spoken about them, but that's okay. We still have time. We're still doing straight line geometry. So I'm going to ask you guys' help to fill in this table. I know you guys know the answers, so I want you guys to participate and help me out here with the answers. Okay, let's look at 2.1. Firstly, we know that the name of this angle is an acute angle. And there where it says description, which is 2.1, the first thing we're going to fill in. I want you guys to tell me basically the sizes of these angles. Okay, so we have a diagram here of what an acute angle looks like. And what do we know about the size of an acute angle? What do we know about it, guys? What do we know about the size of an acute angle? I know you guys know this, so I'm just gonna give you guys some time to think about it and type your answers in the chat. But the question is, what do we know about acute angles? We're filling in the description now. Okay, so let's go, guys. Anyone? Anyone? I think Iman just joined. Iman, you made it to the leaderboard this week. Well done. Well done. Nice, thank you. So, an acute angle is an angle that is less than 90 degrees. Now, if you can see here in the diagram of the angle, it depicts that it is less than 90 degrees because a 90-degree angle would go up there. So this is very obviously a smaller angle than 90 degrees, and that was 2.1. Wonderful, guys. We're off to a great start. Now let's look at the diagram in the next one for 2.2. Now with this one, there is one very obvious symbol there that shows you, and it says in our description, the square on the diagram indicates 90 degrees. What do we call this angle? That's correct, Seth. That would be a right angle. So 90 degrees, we all know. I think this is the most popular, most well-known angle probably because everybody knows it, right? If it's 90 degrees, then it is a right angle. So here where it says name, it's a right angle. Spelling nearly dribbled me for 1 second there, but it's fine. We're good. So we've covered acute, which was less than 90 degrees, and right angle, which is exactly 90 degrees. Now let's look at the next one, which is an obtuse angle. We have a description that says it's between 90 and 180 degrees. Obviously, you guys can't exactly draw what this looks like for me, so I'm going to do the diagram on the side over here. So an obtuse angle is greater than 90 but less than 180. So it is definitely not a straight line. It is more like that. So this whole angle over here is your obtuse angle. Okay. That is more, and since they're labeling all of these, this can be A, O, B. All right, guys. And then when we move on to the straight line angle, which they have depicted for us in a diagram over here, based on what we spoke about last week, angles along a straight line. What is the description for my straight line angle? Description, remember, is the size of the angle. There we go. It is exactly 180 degrees. Wonderful, guys. Now we go to a reflex angle. Now there's a lot of confusion between obtuse and reflex, but let me show you, okay? Now reflex angle is between 180 and 360, so it can look a lot like an obtuse angle. If I use the same diagram I used here for obtuse, AOB, this time my angle will be on this side because it is much greater than 180. Okay, So think of it being on a straight line, the straight line angle, and then you pull this head even further that way. So then it looks a lot like that. Excuse my drawing skills, guys. You get the point. But that is what a reflex angle is. And then what about the last one? This angle goes all the way around. The start and the ending point are the same. What do we call the last one? The name of the last angle? 360 degrees on the dot. A full rotation. Okay, let's hear, guys. What do we call it? It's a revolution. A revolution. Okay, guys. Are we good? Can I have a thumbs up, thumbs down on descriptions of angles? I know we didn't cover this the last time, but we were supposed to because that was our angles lesson, but that's fine. Wonderful, wonderful, guys. Okay. Now let's see. Okay. We are going to speak about intersecting lines today. We already did, okay? But now we're just defining them on top of the little bit that we spoke about them. Mainly the last time it was about angles, and we're just going to emphasize today that those angle relationships come from intersecting lines. So unless you have two or more lines that intersect, you cannot have all of those vertically opposite, straight line, complementary, supplementary angles. Okay, there has to be some sort of intersection somewhere. So intersecting lines are two or more lines that share exactly one common point. So that means how many times are they crossing? I'm not sure why my handwriting is going sideways here. How many times do they cross each other? Only once. Okay, guys. So one common point. Why is it impossible for these lines to have more than one? Because they have to be two straight lines. Now, a straight line will not change direction. For instance, if a line is going up, that is straight, it can't come back down. Only a curved line would intersect twice. Do you guys see that? So this common point exists on all these lines, and it's called the point of intersection. Take note of the following. The intersecting lines meet at one and only one point, no matter the angle. So even if you have intersecting lines like those that make a obtuse angle over there, there is never a point where these two lines are going to cross again. There is only one intersecting point, which is there, the intersection, and there will not be another one. Are we with me? The second one is no two straight lines can meet more than once. Okay, just purely for this reason. If it is going up and it crosses once, that's it. None of these lines will change direction and come back and cross again. All right. And the lines that meet at more than one point will not be a straight line. At least one of them will have to be a curve, like I showed you here. In order for them to cross, they have to be curved. Now, I want you guys to look at this picture over here and tell me, how many intersecting lines do you see? How many intersecting lines do you see in that picture? Let's hear what you have to say. How many intersecting lines do we see in this picture that is on the screen right now with the arrows? Let's hear, guys. We're just counting, and then I want you guys to tell me how many intersecting lines we see. Okay, Dumi has an answer. Can I have more responses, please? There's about 18 of you in here. I know I can get way more responses than that. So Dumi has an answer for me. Thank you. Hafiz, is that how I say your name? And Ronnie has an answer. Or is it Hafiz? Just correct me if I'm wrong. Okay. So yes, guys, we have 4 intersecting lines. Okay. This one starts all the way from there to there. And then we have another one that goes all the way from down here to up there. And then there's another one that goes there. That's the third one. And then you can clearly see there's a fourth one over there. That highlighting was horrible. Okay, but they only all have one intersection. And that's because these are all straight lines. What do these arrows at the end of the lines indicate? These ones. My arrows are indicating that this line just keeps going on and on and on and on forever, right? So it is not going to be curving and coming back down at some point. Are we with me, guys? And of course, it is fitting for us to speak about non-intersecting lines. That is, two or more lines that do not intersect. They are non-intersecting lines. But what is the name for them? Just look at these two lines that are on the screen. There's a special name we call two lines that will never intersect. What is that special name for those lines, guys? Two lines that absolutely never intersect. There we go. These are called parallel lines. Parallel lines. Okay, so if lines intersect, they cannot be parallel. If lines are parallel, they cannot intersect. And what do we use to indicate parallel lines? Does anybody know? How do we show that these lines are parallel? Remember, in math, you never assume. I know you see two lines there that look like they're never going to cross, but there's a certain way we use to indicate on the line that these are parallel lines. What is that way? Let me hear in the chat. I know you guys know this. There we go. We use little arrows. Okay. So on the lines here, I'm going to use an arrow and an arrow. Okay. If we have more than one pair of parallel lines, the second one, I'm going to use two arrows to show that they are parallel, and so on and so forth. Okay. All right, guys, we understand the difference between intersecting and non-intersecting. Can I have my thumbs up, thumbs down? Then we're going to get a little bit, working a little bit, practicing a little bit. Okay, wonderful, wonderful, guys. Great. Now, we are back here, right? I said to you in the beginning, all the angles we spoke about in our last lesson are a result of intersecting lines. And before we go anywhere and answer this question, how many intersecting lines do we have here? In this specific question, how many intersecting lines do you see here? Let's hear, guys. What do you say? Okay, I have a 2. Okay. 3 people are saying we have 2 intersecting lines. 4 people. 5. Okay, so I obviously have to clarify something here. Now, I'm assuming your 2 lines are this one. My highlighting has gone out the window, but you guys will just have to bear with me. And that one, right? But this line, guys, even though it does not go through, what can you tell me about this little line, the yellow one? What can you tell me about that line? It's also a line, is it not? And it's a straight line, and it also touches or intersects with another line. So there are actually 3 intersecting lines here. I know the misconception is the line has to go right through, but even if the line just touches, that is an intersection. Are we with me, guys? I'm hoping you understand this. So don't be misled or confused by thinking that the lines have to completely cross to be considered intersecting lines. Even if they just touch, that is an intersection. Are we with me, guys? Okay, now let's answer this. Identify each pair of angles as adjacent. So we're going to identify these pairs as either adjacent, vertical, a complementary, or a supplementary? Great, let's get going. Angle 1 and 2. Angle 1 and 2. How would you classify or identify those two angles? Maybe I should get rid of the highlight now for you guys to see properly now. Angle 1 and angle 2. Beautiful. To me, they are adjacent. Adjacent because why? What did we say are our reasons and conditions for adjacent angles? Adjacent. They share a common arm, which is this one. They share a vertex because they all start at the same point, and they're both on the same side of that vertex, right? And of course, they are on either side of the common arm. So 1 and 2 are definitely adjacent. Great. Next one, angle 1 and angle 4. Now, wait, okay, let me first keep quiet and wait for you guys to identify what these are. This is angle 4, and this is angle 1. How would you classify those two angles? What do we say, guys? How would you classify those two? Yes, okay, I was worried that you guys don't understand that this vertical, because the way they said it, that's not the correct way we say it, guys. How do we actually say it? We don't say they're vertical angles. We say they are what? Vertically opposite. Thank you. So these are vertically opposite. Okay. And we know this because A, we have two intersecting lines. There's the first one. There is my second one. And they're on opposite sides of the vertex. That's why it's vertically opposite. This is my vertex here. 1 is on the left-hand side and 4 is on the right-hand side. So these are vertically opposite angles. Lovely, guys. Let's move on. Angle 3 and angle 4. Angle 3 and angle 4. 3 and 4. What do we say about those ones? Angle 3 and 4. There's actually two possible answers here, but I want to see. There are two possible answers here out of the words that they gave us. They never said we can only use the words once. Do you guys agree? They said identify them as whatever. So, okay, there's two possible answers. That's all I'm saying. Can I hear your answers, guys? Angle 3 and angle 4. Angle 3 is way, maybe I should use a different color. This is angle 3 and the green one is angle 4. How would we classify those two? Nice. Firstly, they are complementary. How do we know that? Firstly, what does complementary mean? Complementary. They add up to 90 degrees, excuse me. So complementary means adds up to 90 degrees. Great. But what other one could you have classified angle 3 and 4? We know they're complementary. First of all, let me say this before, in case someone is confused, because of this block over here that's telling us that that angle is a 90-degree angle, which is 3 and 4 together. Okay. So they are complementary, but also what are they? What else are they? They are adjacent. Yes. Okay. So you could have also said for them, they are adjacent because they are in fact next to each other, aren't they? These are also adjacent. Right, let's look at the last pair, which is angle 4 and angle 5. There's angle 5 over there. There's angle 4 over there. What do we say about those two? They are supplementary because they add up to 180 degrees. How do we know that they are supplementary? Add up to 180 degrees. How do we know that these are supplementary? Besides the fact that that's the only word that was left. Supple. Think of the properties of angles that we just spoke about now. How do we know that angle 4 and angle 5? If I do this to show them together, what does that tell us? What type of angle tells us that it adds up to 180 degrees? If you look at 4 and 5 together, they make up what type of angle? A straight line. Okay, guys, look here. Straight line, and this angle starts all the way from one side of the straight line to the other side. So that tells us that it is equal to 180 degrees. Can I have a thumbs up, thumbs down on this classification of angles? Okay, I see thumbs down from Reratile. Reratile, do you have a question? And Hafires. Hafires and Reratile, you guys both gave me thumbs down. I don't know if you want to unmute and ask your question or just type it in the chat. But if you would like to unmute, you will be able to now. So go ahead and unmute. Either Reratile or Hafires. I feel like I'm saying your name wrong, but it's fine. I'll work on it. Okay, we're gonna just wait for those two questions. I'm assuming you're typing them in the chat. So I'm going to just wait for them. While you guys look at this, read the instruction very carefully and tell me how to solve this. How am I going to solve this, guys? Read that instruction very carefully. It's less straightforward than you think. Okay? It's less straightforward than you think. Okay, how far back though, Reratile? If it was in the beginning of the question, I'm going to have to ask you to please watch the video because I cannot go through all of it. Okay. If you lose connection, guys, remember there are videos available. That's why I'm recording. Okay, guys. Has anyone looked at this and tried to figure out what they are asking us to do here? Because they're not asking us what you think, probably, but I want to see if anyone actually read this question. It says, show that ABC is a straight line. So that's not as straightforward, is it? That is not as straightforward. So let's see. If I say show that something is a straight line, how am I going to do that? Can I have any ideas? Any ideas? How would I show that ABC is a straight line? It's here. Look at the first one. There are no unknown angles there. They gave us all of the angles. Nice. We just add up the numbers for the first one. The first one is pretty simple and straightforward. So I'm going to say, number one, 49 degrees plus 41 degrees plus this 90 degrees equals. Okay, just do those add up to 180 degrees? Do they add up to 180 degrees? Yes, they do. This is 180 degrees. Now, one thing that would let you or make you lose marks here is writing the reason. Why can I not write the reason angles on a straight line here? Remember with geometry, it's always statement, reason. But in this case, I am not doing that, right? Why am I not writing the reason? What do we think? Because we are determining if it's a straight line. Now, if you go after this and you say, Angles in a straight line. There goes all your marks because you are already assuming it is a straight line. So after you do this, you need to conclude. So you're going to say, therefore, A, B, C is a straight line. And in your reason section, there's no, okay, there is space here. In the reasons, you can say, I say that because these are supplementary. Spelling went right out the window for 1 second. Okay, so your reason can come at the end. You can say, this is what I was trying to prove, and now I'm concluding that this is in fact a straight line because my angles did add up to 180 degrees. Now, number 2 is not so straightforward, is it? Is there anyone who has figured it out? Is there anyone who figured this out? It would be very easy if we knew this was 180. Do you guys agree? It would be very easy if we knew this was 180. But we don't. So how do we solve this one? I'm going to write my supplementary at the bottom while you guys think. I know you guys can figure this out. What do we think? What do we think, guys? Okay, do we have any ideas? Even if your idea is not complete and you know exactly what to do, just an idea of where you think we're going to start with this one. What would your step 1 be? Like, what would you just... Okay, here's a clue. Here's a clue, right? If you knew this was a straight line, so you knew that all those angles added up to 180 degrees, what would you do? That is a very serious clue that I just gave you now. What would you do if you knew that those added up to 180 degrees? What did you do, guys? Okay, well, you would add all of them and say they're equal to 180. Are we with me? Can I have a thumbs up here? You guys are very quiet. I don't know what's going on. Can I have a thumbs up? So if you knew for sure that ABC was a straight line, you would have said x plus 160 minus 2x plus 20 degrees is equal to 180 degrees. Now, we don't know that, but the way they drew the sketch was to confuse you because, lovelies, if you look on this side of life, what if you included that guy in the calculations? You have a piece of information that is very valuable. And that piece of information is what? Angles going all the way around equals what? And you know they are going all the way around because you're going to start at one point and end up at exactly the same point. What if we added everybody going that way? Then your sum will not equal 180, but equal what? We can't use the 180, so I'm going to use the 360. Do you guys see the vision? So instead of saying all of this equals 180, I'm going to say x plus 160 minus 2x plus 20 degrees plus what? There's one more thing missing. Plus what? What's missing, guys? There we go. And where do we get that 180 from? Seth, where do we get that 180 from? I'm looking at the sum and there's something that's going to mess up my life here. Does anybody see what it is? I calculated ahead and now my head is like, no, something is off. Can anyone see what's off with the sum? I just realized it now because I didn't check it earlier. Can anyone realize what's wrong with the sum? I'm going to give you guys a few seconds to check and see if you can realize what would be wrong with the sum. If I continued, okay, Seth just says x. Can you elaborate? What is wrong with the sum? What is wrong with the sum, guys? I know you guys can see it. No, look at the calculation that I just wrote down now, right? You guys agree that going all the way from there to there is 360. Great. But look at what I just wrote. Look at the sum here. Or rather, go to the next step. Okay, what would you do next? Let me say it like that. What would you do next in a sum like this? What would we do next in a sum like this? Come on, guys. Seth is not the only one in the class. We would add the like terms. Now try to add the like terms and tell me what happens. I know now you're going to see the problem. What happens if you try to add the like terms? Well, these guys, what happens with them? Look at the x's. They vanish. Do you guys see that? I can't be the only one who sees that. If I try to add my x like terms, I'm going to say x plus x minus 2x, and it's gone. Now, what are we solving for in that case? Problem. Nah? Big problem. So now I don't know if it was an issue with the printing of this book. Could just be a mistake. So maybe we can do something like saying, okay, no. Then I'll have to change the whole answer. Never mind. Never mind, guys. We'll start here in the next lesson after I figure out what to change. I'm going to change one of these variables to fit or suit us. Okay. Or we can just add them. Who said it? No, it's not Seth. Never mind. Guys, I made this way more complicated than it needed to be. What happens if you just add the things on the one side? X plus 160 minus 2x plus 20. That was not that complicated, guys. I'm having a brain fart moment. My eyes are even ringing. My ears are ringing. What happens after I add it, guys? What happens? X plus x minus 2x is what? X plus x minus 2x. Lenomta's laughing that I said my eyes are ringing. Yo, I'm going through it, guys. All of it. It's 0. The x's are gone. And then you're just left with 160 plus 20 degrees, which is what? 160 plus 20. And that gives us... That was so simple, guys. We went through a lot for nothing. That gives me 180 degrees. And of course, therefore, it's still ABC is a straight line. And your reason is the angles are supplementary. There we go. Whew. Can I get a thumbs up, thumbs down? Did we understand all of this? My brain hurts. Reratile, I see you with me. Where is Hafayas? Are you with me? Okay. There we go. Onami, do you have a question? I see your hand is up. Onami, you can unmute if you have a question. Or it could have just been a mistake and you were trying to do thumbs up. There we go, unmute. Okay. It's okay. It's okay. Right. And now we just go back to the easy stuff because my brain obviously can't handle it. Now, we know these are straight lines, okay? So we're going to do statement. And whoever wasn't here in the previous class, I did speak about different reasons that we can use. So if you weren't here in the previous class, excuse me, please go and check those reasons. I'm just going to do this so that it looks neat. There we go. Let's go. Number one, it says calculate the value of the angles that are indicated by small letters. So in number one, that would be the little x, and then we have a little y there. And in number three, we have an x and a y. Okay, let's go with number one. How would we go about number one? What do we say? How do we go about number one? Looking for x. If you know ABC is a straight line. So I know ABC is a straight line. There we go. That's always where I want us to start. Beautiful. Okay. So you say x plus 44. Can I have my reason while I'm writing this down? Plus 90 equals 180. And I hate this habit, so I must stop doing it. Degrees. Okay. And my reason is it just adjacent angles? They're not adjacent only. They're adjacent angles on a straight line. Now, if you weren't here in previous lesson, this is what I was talking about. These little abbreviations, they are accepted ways of doing it, okay, even at school. So don't come up with your own, otherwise the teacher will take a very long time trying to figure out what you're saying. Just go and find reasons. They should be in your textbook somewhere, the ones that are acceptable, and use those. Okay. And then now we have made a statement and the reason. How do we get x on its own? Seeing that we are solving for x over here. So what is my next step going to be? What is my next step going to be? I have to get rid of, not substitute, but I have to get rid of this 44 and this 90. Okay, so I'm going to take them over to the other side. What happens when you use your inverse operation and you take them over to the other side? It's going to be 180, nice guys, minus 44 degrees, minus 90 degrees. Therefore, can I have my calculator buffins there? Or people who doing mental math. The last time I tried, it went south, so I'm not. Let's get a 180 minus 44 minus 90, and that would be, thank you, Seth, 46 degrees. Okay, that's number one done. Let's look at number two. Number two is pretty short, right? What do I write? What do I write for number two? Minus 46 from 180. Is that for number two? That was the answer for number one. Remember, now we're doing this guy over here. We're doing y. This one. Does anyone remember? Yes, and what is my reason? Nice, guys. Y is equal to 86 degrees. Great, and these are vert, up, angles. Now, if you don't say the word angles, as a teacher, personally, I would not mark you correctly. I'm very strict with such things, okay? In the chat, it's okay if you leave it out, but I need you to take notes in a paper when you are writing. You have to write the full reason. All right, guys, let's look at number three. I have an X and a Y. I don't know where you guys want to start. You can actually start wherever. The reason we have reasons, that sounds terrible, but the reason we use reasons is because there's so many ways to solve this. I can see at least a few ways that I can solve y and a few ways that I can solve x. So Seth has already solved it. Y is equal to 32 degrees. What's my reason? Yes, vertically opposite angles. And another thing I've seen in a paper, just because you use vert-op angles for number 2 doesn't mean it carries over to number 3. You need to write it again, right? I know it's tedious, but you need to write it again. All right. Now we know that y is also 32. And how am I going to get x? How will I get x? There are a couple of ways to get x, but let me hear what you guys have to say. Yes, and you know what? Thanks for bringing that up. I would use this straight line instead of that straight line. That was terrible, but you guys get the point. Why would I use the first one instead of the second one? While I write this down, I want you guys to tell me why. X plus 90 plus 32 is 180. And this is adjacent angles on a straight. Why would I use the red straight line, which is actually, I could have just made life easier by doing this, that one, instead of this one here with the y? Why do you think, guys? I know you guys are sort of suspecting a reason. Why do you think that is the case? Thank you, Seth. Every number in the red straight line is given besides x. Now, you can use y to find x, but what happens if you made a mistake? For instance, if I made some sort of calculation error and I got y is equal to 42 degrees, and if I use this 42 degrees, that means I also have x wrong. Do you understand why it's not a good idea? So if you can use given numbers, always try to use them. Then you only have to lose marks for one of them and not all of them. Does that make sense? So be careful, okay? Now let's transpose everything to the other side. Therefore, what is that going to give us? Therefore, x is equal to 180 minus 90, which is 90, minus 32 is what? 48. Nope, that was terrible. 58. Can I have a calculator person to please try? Because obviously my brain is not reliable at this moment. What is my answer? There we go. 58 degrees. Okay, let me zoom out. If you want to take a screenshot, guys, you're more than welcome to do so. All right, can I get a thumbs up, thumbs down while we're doing our screenshots? Nice, guys. Great, great. Okay, I think we deserve a brain break. I'm tired. Is there anyone who wants to speak to me for a brain break before we come back to these guys over here? Anyone who wants to speak to me? There we go. Elam, I'm going to allow you to unmute now. You can unmute yourself. Hello.
Hi, ma'am.
Elam, would you rather break the camera of your phone or the screen of your phone?
Camera.
You either have really bad pictures or you can't see what you're typing. So, which one would you prefer? Camera.
Camera.
So you'll take pictures with someone else's phone. I see guys. Is anyone saying they'd rather break the screen? I haven't seen anyone say, there we go. Why would you rather break your screen? Ah, there's two of them. Guys. Oh my goodness. Okay, the next one. Would you rather forget the words while singing in public or sing off key? So you either sound really strange or you're saying the wrong words altogether. Which one do you prefer?
Off key.
But you want the right words as long as you sing off key. Ah, guys, I'd rather forget the words. It's fine. I'll make up words. It's fine. Guys, you know how hard it is to come back on key. It's when you lose it, you're me like, what? Then it's gone. That time people are like, "Oof, nobody can help you with keys, guys. At least people can shout the lyrics, but with keys, it's shy. It's shy. Just get off the stage. Exactly. If you have social anxiety, and people are always like, listen to the person playing the instruments. But then you hear good man, I'm off, even though I'm closing my ears and it's like, it's fine. That's happened to me before. It's not funny. The next one, would you rather have no eyebrows or no fingernails? So like just skin, no nails, nothing, just like plain skin.
No eyebrows.
Guys, do you know your face looks swollen without eyebrows? Elam,
No eyebrows.
do you know that your face looks very swollen without eyebrows?
I'll look like Mona Lisa.
Ah, she doesn't look well. So you are in cahoots with someone who doesn't look well, I guess. But also the fingernail thing is very strange. Stop laughing. You guys are laughing so much. Stop it. And the last one, would you rather give up ice cream or give up pizza for the rest of your life? I know my answer, but I'm gonna wait for you guys so I can judge you. Let's hear.
Ice cream.
Same. I would rather give up ice cream, guys. I don't have a sweet tooth. I don't even remember when last. Okay, that was a pure lie, guys. I had ice cream like yesterday. But the point is, right? If I had to choose between ice cream and pizza, ice cream can go. I don't care. Okay, guys. So what's left of our lesson is a little bit of an introductory, you know, a little bit of an introduction rather to our next lesson where we speak about lines that do not intersect. Now, obviously, if we spoke about intersecting lines today, it is fitting that we have our next lesson on non-intersecting lines, or rather parallel lines. Now, does this stuff look familiar to you guys? Can I get a thumbs up, thumbs down on whether this stuff looks familiar to you guys? It's okay if it doesn't. You just be honest and say, I've never seen this ever. Okay. So it seems all of us have seen this before. And these are the three rules or the three special angles that involve parallel lines. Now, the first one is corresponding angles. So corresponding angles lie either above or, well, both of them have to be above or both of them below the parallel lines. This is what they mean. This is my parallel lines, ne? Do you see that these are both above the parallel lines? And these ones are both below the parallel lines. So they either both have to be above or both below the parallel lines and on the same side of the transversal. What is the transversal? Let's see if anybody knows. Which one is the transversal? Anyone? The transversal is the line that crosses both of these parallel lines. So it's this guy over here, this one. So they're both on the right of the transversal, and they are both at the bottom of the parallel lines. And in other words, they make a F. Look, this is upside down, but it's still a F. Okay, this is the wrong way around, but it's still an F. So those angles will be equal. Equal. All right. The next one is alternate angles, not alternating or alternative, alternate angles. Okay. Now these ones are on the opposite sides of the transversal and between your parallel lines. So these are my parallel lines and they are between, which means they're both inside. There we go. There's one of them. There's the other one. And my other condition is they are on opposite sides of a transversal. So if this is my transversal, one is on the left, one is on the right. Okay, if this is my transversal, one is up, one is down. They make a Z or an N shape, and these angles are also equal. Right, and then my last one is co-interior angles. Now, these ones lie on the same side of transversal, so they're either both on the left-hand side of my transversal or on the right-hand side of my transversal, and also between the parallel lines. Now, these guys are not equal, but they are supplementary, so they add up to 180 degrees. Okay, so this is where we're going to take off in the next lesson.